Welcome guys. In this video we will discuss about stack data structure and how we can use the STL container stack in C++. So let's start. What is a stack? A stack is a kind of linear data structure that works on last in first out principle. It means you can insert any number of elements in stack, but removal from stack will be in reverse order only. Element added last in the stack will be removed first. Imagine a stack of plates where you can add or remove plates from the top only. Stack data structure works like that only. For example, this can be considered as a stack. Now in this stack we added the element in this order. First A, then B, then C, then D, after that E, and in the last F. So element added in the last is F, therefore it will be at the top of the stack. Now if you try to remove any element from the stack, you can remove that from the top only. Similarly, if you try to push any element into the stack, it will be added into the top only. So stack provides three different kind of operations. First one is top. It will return the element at the top of the stack. Second is push. It will push the given element to the top of the stack. Suppose as of now at the top of the stack is F. If we try to push G, then it will be at the top of the stack. It also provides another operation pop, which can remove the element from the top of the stack. Like here at the top of the stack is element G. If we call the pop operation, it will remove the element G from the stack. Now let's move to the part where we can use the stack in C++. In C++, the standard template library provides a template class stack. It is also known as adapter container because internally it uses another container for the stack functionality. Like by default, it uses the deck container. Now to declare a stack object, this is the syntax we can use. In the template parameter, we need to provide the data type while creating a stack object. But before that, always remember to include the stack header file. Now this is the syntax of creating a stack object. As the template parameter, we have provided the data type. Data type denotes the type of element that this stack object can hold. For example, if you want to create a stack of integers, then you need to pass integer as template parameter. Similarly, here we are creating a stack of strings and we are passing std string as template parameter. Now it's clear how we can create a stack of integers or stack of string. Similarly, we can create a stack of any data type. For that, we can pass a data type into the template parameter while creating the stack object. Now let's move to the next part. Here we have created a stack of integers. Now the stack class provides a function push. It accepts an element as argument and inserts it at the top of the stack. For example, here we are calling the push function with element 11. So suppose this is our stack. So after this line, it will insert 11 at the top of the stack because stack was already empty. Then we call the push function with value 12. Now 12 will be at the top of the stack. After that, we call the push function with 15. So now 15 will be at the top of the stack. So if we call the top function now, it will give us value 15. The stack class provides the function top, which returns a reference of the value at the top. Remember, it returns a reference, so we can also change the value at the top. Like here, we call the top function on the stack and it returned a reference. Then we assigned a new value 200 to it. After this line, the value at the top will become 200. So if we try to call the top function again, it will give us 200. So this is how we can use the push function to add elements into the stack, or basically add elements at the top of the stack. And we can also use the top function to access the element from the top of the stack. Let's see another example. Stack class provides a function empty. It returns true if the stack is empty or it contains no element. For example, in this line we have created a stack of integers, but we didn't push any element into the stack. Therefore, stack is empty. So if we call the empty function on this stack, it will return true because there are no elements in the stack. Now let's see another functionality of the stack. So stack class provides another function size. It returns the number of elements in the stack. For example, here we created a stack of integers, then we pushed 3 elements into the stack. Now if we try to call the size function on the stack object, it will return 3 because there are 3 elements in the stack. Let's move to next part. How to remove elements from a stack. Stack class provides a function pop which removes the element from the top of the stack. Let's see an example. Here we created a stack of integers and then we added 3 elements into it. First we added 11, then we added 12. After that we added 15. So element at the top of the stack is 15. So if we call the top function now, it will give us 15 as output. After that we call the pop function. Now pop function does not return anything. It just removes the element at the top. So when we call the pop function, it will remove the element. And the top of the stack will be 12 in this case. So therefore if we try to call the top function, it will give us the value 12. So this is how we can use the pop function to remove the element from the top of the stack. But remember a point. When you are using a top function, it will give you the value from the top of the stack. And when you are calling the pop function, it will remove the value from the top of the stack. It will not return anything. But if stack is empty, then in that case both of these functions can result in undefined behavior. Therefore, it's always suggested that first check if stack is empty or not, then only call the top function or pop function. Now let's move to another example. How to iterate over all elements of a stack. Now stack provides a function to access the element from the top, but it does not provide any random access operation. It means you cannot directly access any element based on index position in stack. So if we want to iterate over all elements of stack, then we need to remove element from the stack one by one and print it on console. Let's see an example. Here we have created a stack and added 4 elements into it. First we added 11, then we added 12, then we added 15 and then 20. After that we started a while loop. In this while loop, first we are checking if stack is empty or not, and we will continue this while loop till stack is not empty. As of now stack is not empty and 20 is at the top of the stack. So we will access the top element and print it. So first we will print 20. After that we will call the pop function and it will remove the 20 from the stack. Now we will check if stack is empty or not. It's still not empty. Then again we will access the top element, and that is 15 in this case. We will print that. After that we will remove that from the stack. Then again we will check stack is empty or not. Still it's not empty. We will access the top element, that is 12, and then we will remove that. After that we will again check if stack is empty or not. In this case stack has one element, but still it's not empty. So we will access that element and print it on console. After that we will remove that element. Then control goes back to the while loop again. Now stack is empty, so the block will exit. So this is how you can iterate over all the elements of a stack. But important point to remember here is that once the while loop ends, your stack is empty. Let's move to another part. How to customize a stack. By default stack uses the DQ as internal container. Therefore stack is also called a container adapter. But if you want to use a vector or a list as an internal container, that you can provide them as a template parameter while creating the stack object. It is an optional, but remember that the container which you are provided as a template parameter should support a random access operator. So this is how you can customize your stack to use different kind of container internally. So that's all for now. So in this video we discussed about the stack data structure and how we can use stack in C++ using the STL container. This video is a part of STL course in C++. For more videos related to this course, you can check our playlist on our YouTube channel This Pointer Academy, or you can also refer to our website thispointer.com. It has the complete free course on STL in C++. Thanks for watching. Don't forget to subscribe to our channel and press the like button.